Hello, we will introduce conditional probability density function in this video. So we know sometimes we want to measure the conditional probability between two variables. For example, in regression analysis, we are interested in studying the behavior of one variable conditional upon the values of another variable. So if we look at this expression, so f x given y, which equals the probability of f x equals x and y equals y. So here the lowercase alphabet x and y are the specific value, particular values we are interested in, and large capitalized x and y are the random variables. So these are two random variables, and we are not only interested in probabilities of x, but we are more interested in the probability of x given the particular value of y. So this is called conditional probability density function. So i.e. the PDF of x given y. And similarly, if f y given x, which equals the probability of y equals specific value y, when x equals specific value x. So this is called conditional probability of y given x. And how to calculate the conditional probability? Normally we can use this expression. So fx given y equals fxy divided by fy. So fxy here for discrete random variables x and y. So this is the joint probability value for x equals x and y equals y. And fy is the probability of y given value is y. But for the continuous variable, we just use this is the density. So the joint probability density divided by the probability density of y function. So you just keep in mind that for the discrete random variables, we can use the probability. Here, all the probability. But for the continuous variables, we can only use the probability density function, because for the particular value in the continuous random variables, their probability, no matter this is joint probability or not joint probability, for the particular value are 0. So this is the difference. And next we show an example, and this is a discrete random variable case. For example, x can be 4 value. So -2, 0, 2, 3, and y can be 2 values, 3 and 6. And at this table, there are 8 values represent the joint probability value, right? Because these are discrete random variables, so their joint probability density function are not necessarily 0 for the particular value. So we can see there are only 2, 0, and 6 values, and their total sum is 1, right? So, and for the previous video, we saw that we can calculate the marginal probability density for the y value, for example, equals 3, and 6 we just sum by row, and for the x sum by column, so we can get the marginal probability. So now if we say we want to calculate the conditional probability density function for x equals -2 given y equals 3. So we just fill in the expression y equals 3, the probability in denominator, and the joint probability fx equals -2 and y equals 3 in the numerator. So we just look in the table. So this is the joint probability for x -2, y equals 3. And because we want to find the given y equals 3, right? Given the conditional variable is y here. So we just sum by this row, get the marginal probability for y equals 3. So this is 0.27 divided by 0.51. The result is 0.53. And you can see if x equals minus 2 is 0.23. But if we know more information such the y equals 3, so in this time f x minus 2 and y equals 3 is not 0.27, is 0.53, right? So under this condition, we get the probability is not the same as we have no more information about the y value. And another conditional probability is x equals 2 given y equals 6. So we just fill in the marginal probability of y equals 6 by row sum. This row, because this is y equals 6, we just sum together. This is 0.49. And x equals 2 is 0.16. X equals 2 and y equals 6, 0.1 right here, right? This is joint probability, and this is the marginal probability for y equals 6. So now just set values in this expression. So the marginal probability of y equals 6 in the denominator and the joint probability of x equals 2, y equals 6 in the numerator. So the result is 0.20. You can see if we have no information about the y value, so x equals 2, y equals 6 is about 0.26. But if we have no information, so x equals value 2 is by this column sum, right? It's about 0.26. And now we get more information. Y equals 6. So this conditional probability of x equals 2 given y is 6 is about 0.20. So this is not the same as the unconditional probability. Thanks for watching.